Great. We have been having just a wonderful time with Climate Conversations Amplified. Thank you all for your interest, your attention. Thank you, Zoom Room, for your attendance. Participate freely. We have a really unique speaker today. But before I introduce Dr. James G., I want to remind anyone who has not yet signed the petition to put a constitutional amendment to the Florida Constitution for clean water, that petitions are on the back. And if you're not a state employee and you are a registered voter, please sign one. Actually, you can sign one even if you are a state employee. You just can't pass them out at work. So today's topic might sound a little dry. We're going to talk about economics and climate change. But our guest speaker, Dr. James G., is a professor here at University of Florida, and he specializes in natural resources and environmental economics. And when we asked him why did he pick economics, he said because he didn't like organic chemistry. And because economics solves problems. What a great way to look at the economy and economics and what it does with climate change. He looks at global pictures, the societal impacts of the way we use our resources and what happens with environmental change. He looks at something called non-market valuation of conservation and lake ecosystem services, but I think that's just a fancy way of saying what's the value of nature in our lives and how do you put a price tag on it? And also, what are the health impacts of climate change and how do you put a price tag on that? His PhD is from Virginia Tech. Before that, he was a Florence Levy K Fellow in Environmental Economics at Brandeis. Before that, he was a student he got his master's degree at SUNY in New York. And before that, he was, it seems to me that Fudan University might be like the Harvard of China in Shanghai. I don't know if I'm exaggerating it, but he got his bachelor's of science at the Fudan University in Shanghai. So one of the things that struck me, besides intelligent, delightful, engaging conversation, is that when you research Dr. Z and you look at student reports, the Brandeis students, 100% of his students said they would take his class again. So we're in for a treat. Dr. James, thank you.
Thank you, Alan. Thank you all of you for having me here. You know what I did? Oh, I'm on recording. Sorry, I'm on recording, right? Okay. I'm not gonna say how I got all of my students to record things. Well, I didn't do anything. Catch me later. No, I seriously, I didn't do anything. Okay. So my job as an economist, and this is I haven't been teaching for the summer, so I might be a little bit rough, so well, just bear with me on that. Okay, so what I'm gonna share with you today is a couple of big pictures, and then how economists think about the whole problems with climate change. Now, I'm gonna use 3 keywords. And those 3 things seems to be interconnected. One is climate, the second is energy, and the third is air pollution. Now, how are they related? And then why is this such a tough problem to solve at a global scale and of course at a local scale where we're all feeling it? Now, I'm first gonna talk about a couple of facts to really think about how these systems are. Am I holding it to? Is it okay? How's it sound? A little higher. Oh, okay. Okay. Now, sort of giving you a picture of how these systems are interconnected, and they seems to be affecting each other. Now, first, energy is really critical for growth. And by growth, I mean economic growth. I have a 2-year-old daughter who is lacking growth, and I don't mean that. We're working on it. Okay, we're working on it. And of course, she needs more energy, but that's not what I meant, okay? Now, if you look at this chart, it seems that there is a very, very strong relationship between how prosperous a country is versus how much energy they use per capita, okay? On the top, we have the United States. Here, our room is fully air conditioning in the 95-degree day here in Florida. Hopefully everyone is comfortable, okay? And everyone on Zoom, hopefully you're comfortable as well. But then if you look at countries like India and China, of course, they're lacking economic power, but then part of that is they don't use as much energy as we do. Okay, I grew up in the city of Shanghai in China. I don't get air conditioning in the 95-degree days. It's rough. And in India, things seems to be worse. They got 120-degree days just this summer. 90% of the people in India don't have air conditioning. And it's bad, right? Now, that's first. But second, energy access is a major problem, okay? Now, what do I mean by that? This is per capita electricity consumption and population. Now, this is a selective set of countries. Canada uses more energy than us because they're cold, they need winter heating, right? They burn a lot. I mean, and there's us, there's China, and there's India, which really uses a tiny amount of fraction of energy than we do. You can imagine they don't have air conditioning. Many of the families in India don't even have electricity access. They don't even have light at their homes. Right? And then you can certainly think about when an extreme heat event hits 120 degrees out there, how do they even sleep? Just imagine that. I now cannot sleep in the 90, like even in the 90 degrees, I cannot sleep. I can't imagine how they're living their lives. But then that's the third point. At some point, people in India and China, which are two of the most populous countries in this world, together they have 2.5 billion people. At some point, they will grow, right? And most of these countries' economy seems to be rapidly growing. I got my air conditionings back in about 15 years ago at my home in Shanghai. And the Indians are catching up as well, right? So we know that while their economy grows, they will use more energy, right? They'll eventually get their lighting systems, get their sanitation systems, get their cars, get their ACs. They're going to use more energy, right? And the hope is that we would want them to live a prosperous life as we do here in the shaded air conditioning rooms. That's a better life than being exposed in the 95 degrees. Now, this is energy demand per capita, okay? Our energy demand has been decreasing a bit. We have been putting a lot of effort into renewable energies. We have been putting a lot of efforts into energy efficiency programs. So our economy is growing, of course. Our energy demand, especially fossil fuel demand, is not growing up. Look at the exponential growth curve in India. Do I need to point? No. Let's see. No, I don't have to. No. Okay. Now, you can see that the red line is really, really low now in India. They're going to grow very, very fast because how these energy demand curves grow, they grow exponentially. Way up, taking off, right? And once, you can certainly imagine when a household gets their energy, installing their air conditioning systems, installing computers, internet, all the modernity that we are getting, that we almost take for granted, that will cost energy, right? The whole system is essentially powered by excess energy. Now, This is projected demand of up until the 2040s. The OECD countries, or so to speak, the developed world, will sort of peak up. We have been investing a whole lot in renewable energies, energy efficiency systems. The non-OECD developing countries, we will expect their energy demand to grow and keep growing because they're at here now. The Indians are using here. They're really not installing some of the basic needs for their lives, and we can't really hold them up for it, right? Now, the first thing about this is this. Fossil fuels are expected to meet much of that growth, as much as we would hope it doesn't from a climate change standpoint. Now, why is that? Oh, before I do, if you have any questions during the talk, please, okay? Now, okay, fossil fuels have been meeting much of the growth in the past. It will, because it's cheap, okay? Now, here, of course, in the United States, we have invested a lot in solars and wind and renewables, hydros. In the developing world, and especially in India, the Chinese seems to be doing similar things on wind and solar, but especially in India and the vast majority of Africa, fossil fuel is really, really cheap. Now, I would like to use this example. Okay, just imagine someone who lives in the in Bihar in India, where they don't even get air conditioning, they don't even get electricity in there. Okay, now suddenly a group of, let's say, USAID workers goes into that village and says, okay, we're going to install solar panels into your village. Okay, what are they going to think about this? Now remember, solar panels in communities, we have been doing here in the United States. Some of you, my neighbor actually have solar panels on their rooftops, and they're getting subsidies for it, right? It's fine, perfectly fine. For them, it's sort of a piece of property. Solar panels are not cheap, and it turns out they can sell it, right? They can sell it to someone who can buy the panel itself. Now, I'm not talking about the electricity that it makes, the panel itself. So if you really give them a very, very expensive, to their standard, a piece of property to them, just think about what they're going to do if they don't even have the money to feed their own families, right? Now, fossil fuels, you just burn it, and it's really, really cheap to burn fossil fuels, right? Now, so which is why we tend to believe that there's going to be renewable growth, but then that growth, fossil fuel is still going to be there, and especially in the developing countries, in India and in sub-Saharan Africa, it's going to be there. Okay, it's not going to go away. Okay, now this is what I showed you earlier. Existing coal. The cost to produce electricity from coal is really low, okay? Now, of course, we're not factoring other type of costs that I'm talking about, but then if you just buy coal from the market, put it into utility, and then burn it, okay? The price of using existing coal to generate energy is pretty low, followed by natural gas, and solars are getting there, but not there quite there yet. Wind is there, but not there yet. Okay, and especially for developing countries where they don't even have the amount of capital or amount of stable governments to run solar or wind programs. You'll probably have to rely on coal and oil and maybe burning wood for a while. Now, any other sectors as transportation as well. Now, this graph is essentially should be read this way. Okay, on the top left quadrant, you have EVs that are cheaper. That is, EV are cheaper than internal combustion engines. And on the y-axis, it's price of oil. On the x-axis, it's price of essentially powered batteries. Okay. Now, for a Tesla Powerwall, which my neighbor have, for it to be as price compatible as an internal combustion engine run vehicle, the equivalent oil price needs to be at $800 a barrel. We're not getting there. No. Okay. Now, The estimated break-even price for the average battery is at about $180 of oil per barrel equivalent to make the average battery cost competitive. Okay. The 2024 forecast from BNEF is about $94, and break-even price of oil is about $85. Okay, so technologies are improving. There are innovations that are being made days by day, years by year. So it's getting cheaper and cheaper. Oil price of $85, we're sort of getting there, but then not quite. Okay, now, which means what? Which means it is still not cost effective for any individual consumer to use battery on its own, to use battery powered car on its own. Okay, it might be better for if we're eating in subsidies, and the government is offering a lot of subsidies for batteries and electric vehicles. But then, if there's not those type of incentives, it's not there yet. Okay. Now, and here's the other problem. Okay, fossil fuel is going to be driving growth, but then are we running out of it? Okay. Now. Some of you might be familiar with this theory. How many of you have heard the peak oil theory? 2. So this is a theory that that's originated in the 1950s by a scientist named Herbert, which predicts that there's not enough oil to fuel human growth. Okay. There's proven reserves, and then there is productions, and then there are future discoveries. And what his prediction is, by the year 2010-ish, we're going to be running at a peak of oil reserves and coal reserves as well. And then because we as an economy, as the globe grows exponentially and population grows exponentially, our oil reserve is going to dry out. So our human society will essentially be doomed. Now, there's a more aggressive version to it, that's the limit to growth version in 1972, where essentially a group of scientists from MIT predicted that exponential growth in population will exhaust fossil fuel and cause a sudden and uncontrollable decline in both population and industrial capacity. Okay. Now, I'm an economist, so I have a very, very simple theory about economics. When something becomes scarce, when something is short, the price tends to go up. I almost think it's universally true, sort of, right? I'll challenge the audience to name one thing that its price goes down when it becomes less ambient. There's things out there that might fit that structure, but then typically not. Okay. Now, why do I say that? Has the oil price gone down since 1972? Or up? That's 1972 is now it's not a coincidence that there is the oil crisis that happens in the 1970s and then this type of theories that are going out. Oil price were up at that time. Now I can show you a graph. There's a hike in 1980s oil price. This is the historical oil price, okay? So, and I've essentially adjusted it by inflation. So what we need to look at is not the price that you get at the pump, but then the price that's adjusted for inflation, which happened during the past couple of years. All right, so inflation adjusted oil price is at $200 per barrel. Last time I checked, oil price is at $70 per barrel today. What does that really say about the abundance of oil? We have a whole lot of oil, right? We have a whole, otherwise, okay, there are two possibilities. The first possibility is we have a lot of oil. The second possibility is we are not using oils anymore, so that it seems more abundant. Last time I checked, we're still using it, right? Okay. Now, here's the essentially reserved production ratio for fossil fuels. This is oil. So this is essentially measuring how many years until we exhaust our oil resources. By the year 1972, where Meadows is putting out his theory, her theory, the reserve to production ratio is about 50 to 1, meaning in 50 years, they predicted we're running out of oil. By year 2020, we're still at 50. Okay, we still have 50 years of oil left. Okay, here's natural gas. You might not be able to see it very clearly. It's the very light green line. It's not going anywhere. In fact, we have more natural gas since the 2000s, where we discovered something called fracking, and then be able to produce natural gas at a much, much cheaper price. Here's coal. We're not running out of it, unfortunately, folks. We probably have, now, the problem here is once we think we're running out of it, the price goes up, and then people go out, set out, and then discover more of the coals in some remote area on this planet. Okay, now, so fossil fuel is not going away. We're not running out of it, so we can't really get out of it, okay? And those developing countries really need it, as last time we checked. The fifth thing, fossil fuel increases pollution that shortens lives, okay? Now, there are 5.5 billion people, 80% of the world, currently living in areas that exceed the WHO safety guidelines for air pollution. Half of them live in China and India. Air quality in those two countries are unhealthy, to say the least. And they can range from unhealthy to outright hazardous from time to time. Now, and now it seems that it's not really India or China anymore. If you look at the news for the past months, we got this. Like, do I have a map on that? No, I don't. In New York City, we got it. In LA, we got it. In the entire Midwest and in the Northeast, when the Canadian wildfire blows, we all got it. And now, these things are really, really bad. Okay. Now, I can talk about a story where we economists have been finding out how bad it is. Okay, so the Chinese are doing now this blue line is it's essentially the river that divides the northern and the southern part of China. Now, what's so unique about it? In the north part of the blue line, they have winter heating programs, centralized. So each city will run their centralized boilers, usually on coal, and then send their heats into people's homes. On the southern part of it, there's no such thing. So I lived in Shanghai, which is just south of that line, and I have to run AC. Our family had to run ACs during the winter. We don't really have centralized heating programs. Okay, now, the problem with running centralized heating programs is that it burns a whole lot of coal. When you burn coal, you generate a whole lot of air pollution. What economists have found is that if you just live just north of that blue line, which is probably going to see about 40 micrograms per cubic meter higher of particulate matters, which is the very, very small particles that goes through your nose into your lungs and into your brains, which the really bad type of air pollution. Your average life expectancy is 3 years shorter. Okay, so you can expect people living just north of the blue line being 3 years shorter in life expectancy than people just living south of the blue line. Now, this is global in the sense that we can actually think about and calculate how much air pollution it is. Now we have that relationship, and then trying to build, trying to build how much average life expectancy is lost due to bad air quality. It's right there. And next to it is smoking. We know smokings are bad. The the average person probably do not know that air pollution is the #1 killer on this planet. It's worse than smoking and alcohol use and unsafe water and road injuries and HIVs, malaria, tuberculosis, conflicts. It's worse than all of it. It's killing people quietly. Lung disease, lung cancer, asthma. There's even studies on linking between air pollution and dementia. So now, because the very, very small particles really go through the nose into your brains, that really damages the brain, and there is a correlation between dementia and air pollution, really bad. Okay, which is my practical advice, not as an economist, but as an average person. If the air is really bad, which we don't really get a lot in Florida, don't go out. Okay, please don't go out. Now, here's the last part of it. Okay, burning fossil fuels is not only causing air pollution problem; it's also causing climate change. Okay? Fossil fuel releases carbon dioxide into the air, and the consequences to that are really, really complicated. Okay? And that's essentially separate from the air pollution, the damage that air pollution is causing to every one of our brains. Now, we know that the climate is expected to change. Okay? So this is the distribution of average temperature in India. It's a pretty hot country, subtropical. The red line is showing 2070 to, I can't see, is it 2070? Let me check. I'll make it slightly smaller. Okay. 2070 to 2099, average. Okay. It's gonna get hotter, okay? India is gonna get hotter, on average. So it is the United States, so is here in Florida. We're probably gonna see a bit more hotter days. How's that gonna matter, okay? Forget the title for a bit. The title says impacts to the United States are minimal. We know that is not minimal. In Florida, we're feeling it, okay? Now, this is essentially research showing that if we have an extra day that's in the 90 to 94 degrees or in the above 95 degrees, how much excess mortality, how many people will die because of the heat waves, okay? And there seems to be a statistical relationship between how hot the day it is and how much mortality it will see. And most of these mortality burdens are in two groups of people. One is infants, the other is the elderly. So my daughter and this audience, unfortunately. Okay. Now, it's bad, okay? This is, I pulled from New York Times yesterday. Heat waves is rampant in this part of season, okay? This is how much damage how much extra spending it is causing for the Medicare program for every person. So national average, an extra heat wave, probably defined as 3 days consecutive of 95 degrees or higher, is costing, on average, the Medicare program $700. Okay. This is Florida, okay? Now, the national average is $700. It's costing every children who is on the Medicaid program, about $2,400 for an extra heat wave. The age group is at 42,000 in Florida. It's, at least in the state of Florida, it's the most impacted group by heat waves. And we can certainly imagine who are the people that are being affected. Of course, it's all of us, but then this is especially hard hit for families who do not own air conditioning system, right? And there is wildfire, which is also exacerbated by climate change. Temperature gets hotter, trees are more likely to burn, right? This is what we see in New York City. bad air quality, and we know air quality, air pollution kills people. Right? Now, the other part of the puzzle is this. The impact to the United States is minimal, as the slide will say, because of what? This is, the red line is what you're gonna see mortality rates in India, exposed to the same amount of heat than the United States, okay? The United States is bad enough. The Indians are 1 or 2 magnitudes, the problems to India is 1 or 2 magnitudes more severe than us. Now, because of what? They don't really have anywhere to go during a 95-degree day. They have nowhere to go. They don't have ACs. They don't have centralized cooling programs setting up at the library. It's really bad, right? Now, so the impact is going to be felt on marginalized communities here, and of course, underdeveloped countries worldwide, countries like India, like China, like in Nigeria, in Uganda. Those are going to be the people that are being most affected by climate-induced heat waves or by climate change in general, because they don't really have the resource to cope with it. Okay? Think about the resource that we have versus the resource that they have. Now, and there lies the puzzle. They are the people that wish to develop and will develop and use more energy, and they happen to be the group of people that are most hit by it. Of course, part of development is essentially closing that mortality gap, right? It's closing that gap. You're not gonna, if you have an AC, you're probably not gonna be hit that hard by heat waves. This is Celsius. I'll do my mini conversion. This is about 120 to 125 degrees in most part of India. Delhi is one of the most populous cities in the world. 10 million people live in Delhi. It's really bad. Now, how do I do our time? 2:30 is I stop. Okay. Yeah. Now, the system is complicated. Okay. Now, what do I think is some of the solutions to it? Okay. In my Yes, so the question is, am I referring to the actual temperature measured or the heat index, which takes into account direct sun exposure, humidity, I believe, and vapor pressure, and sort of pressure of that. There are different metrics to it, and we know that a hot day, if you're exposed directly to sunlight, it's gonna be feeling hotter and hotter. This one is measured by heat index. This graph you're gonna see is raw temperature. It's just raw temperature. It's not heat index. So it's air temperature. It's 50 degrees, it's 125-ish. This is not heat index. And if you really calculate the heat index, it's gonna be even higher if there's no rain. Yeah. Thank you. Now, what to do about it? Okay. The best thing that I can think of, and I know many economists would agree with me, but then probably not the general public, and we'll see why, is essentially to price energy and essentially pricing all carbon emissions at its full social cost. What do I mean by social cost? Okay. Now, when I is dining earlier today, I ordered a burger. That piece of burger has a patty of steak on it. Okay. I'm paying, well, I'm technically not paying anything, but if you order at a regular restaurant, thank you all for your treat. If you order at a regular restaurant, it's probably $15. Okay. Now, that $15 factors what? Factor the cost of the beef. Okay, so they get it from CAFO facilities, the waiters, and then the cooks that cooks it. Okay. What's not in there is its air pollution. Well, it's its climate impact and its water impacts. I'm almost sure it's not in there. 99% sure. Okay. So I'm not paying for it. Okay. And how large is that? The new numbers that just came out last year by the EPA is sitting somewhere at $190 per ton of carbon emission. Okay. Now I have a number for it. Okay. I actually buy this at the Whole Foods. They offer this thing. This is the amount of emission that you're gonna get from a glass of milk. Okay, just like probably this large. It's 0.6 kilograms emission. Okay. If we'll do the math, this amounts to about, no, my math is wrong, Adam, sorry. I'll do the math quickly. If you're drinking a cup of milk every day, it's with the social cost of carbon, it's about 10 to 20 cents. Sorry, 10 to 20 cents additional cost just by drinking the milk. Are we paying for it? No, right? Now, this number has been, it was previously at 50, and then during the Trump administration, they revised it down to $7, which means what? Which means for the cup of drink that you drink, the Trump administration is saying it's costing about a 1/10 of a cent-ish, right? I won't go into the details, but then there are many wishful thinkings in that particular analysis that's per scientists. All right, now, so how do we use that number, okay? This is, the blue bar is the current cost of different sort of energy production methods. Conventional coal, natural gas seems to be pretty cheap these days. Hydro, nuclear, and wind and solar, okay? Now, conventional coal is now still at least 40 to 50, I had the number, 30 to 40% of our grid is powered by conventional coal combustion, okay? And you can see why, it's cheap, okay? We don't have that much natural gas to play around with, so our base load is essentially met by, our peak load is essentially met by conventional coal, okay? The green bar essentially shows you after accounting for a $50 per ton cost of carbon, which is essentially part of the mortality cost that I show you that heat wave actually kills. This is how it compares, okay? Conventional coal is much more expensive than some of the other sources, including wind, solar, natural gas, nuclear, and hydro. With the new number from the Biden administration, it's probably even higher. This is a non-greenhouse gas costs, which mostly is coal burning costs air pollution, which also costs lives. See how much it is, how expensive it is to really burn coal for energy. It's really, really expensive. Now, the problem here is in our current energy system, in our whole market economy, we're not really addressing the green part and the red part. Economists can calculate how much they are, and we sort of have a good idea of how large the green bar is, how large the red bar is. We're nowhere near accounting for that in our whole economic system at all. I mean, there are attempts. These type of attempts the closest that we have achieved accounting for the full green bar is in 2009, where the Obama administration tried to advance a cap and trade program for carbon. It eventually gave way to Obamacare for political reasons. And then one of the attacking points for that bill is it's a tax. Okay? Now, what that is, it is a tax. Now, if you really think about the cup of milk that you're going to drink, and the Obama administration is really saying, hey, you're going to pay 20 more cents on the cup of milk. Now, you can certainly imagine how the regular voter are going to feel about paying 20 cents more on a particular bill. They're not going to like it, right? Which is why it's not going anywhere. It died 15 years ago. It's not going anywhere in this country. Okay. Now, without that, this is what we get. Okay. Airlines are selling carbon offsets. The carbon offset is, if I point to you, from a flight from New York JFK to London Heathrow is costing you $600-ish. The carbon offset is $6. Not nearly enough. We're getting the climate neutral milk. Of course, consumers are paying, you get at Whole Foods, so it's slightly more expensive. Right? It's essentially the government asking us to front the bill. Okay, if you're buying into this, if they're really carbon neutral, then we're doing our parts. But then it's not the government asking us to do it. It's we voluntarily do that. And then think about why are they not selling these type of milk at Publix? Like, people are not buying that at Publix. And this is that. If you got an EV from the state of Colorado, apparently these days you get $26,000 back from the government. A lot of money back from the government. Okay, that's part of the Inflation Reduction Bill and then state programs running in Colorado. Now, of course, people are going to buy EVs just to get the money. I have to admit that I bought an EV last year. I got money from the government because the government pays me money. You just take it, okay? Right? I mean, like, if the government hands you free money, like you'll be silly not to take it, right? And this is now what I got is about $7,500 from the federal government and from the state. I bought it in New York. This is a lot, okay? Now, but the problem is, think about what this program is not doing, okay? If you're paying $26,000 for people to buy EVs, you're damn sure that people are going to buy EVs. But then the problem is what? I don't really need an EV. I can buy EV and get money from the government. I used to bike. Then the government hands me a whole load of cash. I don't bike anymore. I drive an EV, which still costs energy, right? Like, I used to walk. I used to take public transits. Now, like, yeah, the government has handing me money. Like, I see that. I seriously want to move to Colorado, okay? Now, it's really creating incentive for people to do the right thing, but then the government will have to mandate or dictate what is that right thing to get it past Congress at all. Like the government, now if we have a carbon pricing program, if we just say, no, the gasoline price is 3 times what it is, that encourage people to buy EVs, that encourage people to go bikes or public transits. It's not creating, instead the government has to do something like this. We're eliminating the transit program, we're eliminating the bike sharing programs, where people are not walking. I want to move to Colorado, right? And buy more EVs. Now, that's one. Though we're not getting there for political reasons, unfortunately. And we're going to see more of these sort of programs. I have other examples that I can run, but then you can also think about other examples where government, our neighbor has a solar panel on their rooftop. The state is paying them money because when their solar panels generate money, it's essentially selling back to the state at a very high price. So they're making money from their solar program. The state is paying for it. Right? That's why my neighbor is doing it. Right? Rooftop solar is not the most efficient system. in this world, it's not even cost efficient, but then government fronts the money. Okay, now, the second one of them is, since we're not essentially letting the market do itself by essentially taxing the pollution, now we can certainly think about investing in innovation. And that's how we get through, that's in fact how we get through the oil crisis, right? There's an oil crisis, OPEC is trying to limit demand, oil price goes sky high. That also happens last year. This year. We just dig more oil. It takes time, but then it's doable, okay? Now, the levelized cost of energy, existing coal, its own cost, production and extraction costs are pretty low. But then this is what it looks like in a time series, in time trends. The cost of solar panels has gone way down over the past 10 to 15 years. It will go further down and due to technological innovation. But then we can certainly start to think about a world where a solar panel can compete with coal and natural gas in the near future. And things will probably change, at least in this country. We're building more solar panels. We're building more wind turbines day by day, right? This is what lithium battery is costing, okay? It's going down and down and down. And this is essentially the technology where it can store energy and then be released so that you don't have to drive internal combustion engine. There are also carbon capture technologies that's potentially usable. Okay. Now there are shale gas which at least solves the air pollution problem of coal. Right. If you can pump natural gas, it's cleaner. It's still causing climate change, but it's slightly better. Okay. Right. And there's a lot of natural gas down in shales in many parts of this world. Okay. Now. We're still not investing enough money into the energy sector, of course. We're investing about 0.3% in energy so far in the United States, in energy R&D. So we can do more, okay? Of course, I would believe this is probably public investments. I mean, Elon Musk is doing his share, no matter how you think about that guy. His company has done some good work, okay? No matter how you think about that guy. Right. Now, I have third point on adaptation and resilience, but then for time's sake, I'll just leave it at that. Okay. All right, so that's all. Questions, comments, really appreciate it. And thanks so much for having me.
I have several questions, but I don't want to hog everything. The first one is I don't understand how the cost of, the energy cost or the climate cost of all of those things. I mean, how do you figure that out? It just seems like it's kind of an arbitrary thing. And the thing, another question is, can you tell me how much fossil fuel energy is consumed for building the the electric panels, lithium, plus the rare earth elements that go into them. You got to dig them up, and then there's the problem of disposal. And the other thing is, I think all the things the U.S. does is good, but when you look at India and China, they use mostly coal and they're building more power plants. I started to say I feel like it's dropping a drop of ink in the ocean, but maybe a drop of ink in a Great Lake would be more appropriate.
A lot of questions, yeah. Thanks. I hope I remember everything. Julia, can you bring the slides back up? Thanks. I'll address it backwards. I should say I don't have full answers to you. I'm still learning these things, but I can say something about it. I think that's why we need diplomacy. especially with China and India as well. John Kerry has gone there several times. I don't think the talk is going anywhere because of what's happening between the two countries. But then if we wish to address, if our goal is to curb carbon emissions, we can't do this alone. Even if we completely stop using fossil fuels, we're not going to solve the problem. Okay, we're not going to curb global warming. What we can think about doing is, of course, building resilience and adaptation frameworks, but that's different. Okay, the world is still warming, and we probably can't prevent wildfires from happening again. The Chinese happens to own 97% of the rare earth minerals, right? To build those batteries, so we sort of also need them ish. I know there are alternatives being developed that that leaves us out of that dependency, but then it's not going anywhere in the next couple of years. Can you? Oh, I can flip. Can you click on the slide again? Yeah, just use the mouse click. Yeah. Okay, got it. Right. Okay. Now. So the first question that you're thinking, the second question, the second question you're thinking about is there's rare earth minerals. We need to extract them. We need to build batteries that cost fossil fuels. That's essentially part of the green line that's in front of the solar PV. And then we also need to build the wind turbines, which are huge, humongous monsters out there. That's part of the green bar is essentially the cost of fossil fuel that we are needing to essentially build that whole structure. So there are costs to it, and then we can sort of calculate how much they are. So it's in there. Mm-hmm.
Good questions, Paul. Okay, who, gentlemen?
Larry Lowenthal. Could you please identify by type what social costs are? The word itself is kind of vague. And secondly, with that, I would suggest instead of presenting them as so many dollars per ton of CO2, you use actual real dollars per year. In 2019, it was US cost this much, social cost, and 2020 and so on. So people can see total dollars. It makes more sense.
Julia, can you go on Google? Google.com. And thanks for the suggestion. We'll just get the number. Go on Google.com and and search for carbon emission of the United States in which year do you want to do? 2019? 2019, that's 1 year before COVID. Okay. Well, I know during COVID, carbon emission dropped by 20%-ish.
The question is social cost is only medical or something else?
Right. So the social cost, in theory, accounts for everything. It accounts for the medical cost of treating heat waves. It accounts for, apparently, when someone dies, the government accounts it for $7 million. That's how the government is counting things. Okay. So the government, if let's say a particular heat wave is causing 100 persons to die prematurely, multiply that number by $7 million, you get how the government is valuing it, $700 million. Okay. I'll finish my thought. There are other type of costs that's accounted for example, sea level rise, and then you have to build seawalls and build other type of structures, and accounting for flooding damages. There are damages to agriculture. Apparently, plants don't grow very well during heat waves. That's part of it. So the quote unquote social cost of carbon is taking all of those into account, in theory, and essentially adding them up.
Add them up and present it is the suggestion.
Add them up and present it.
Okay.
This is not right.
Which part is not right?
14.67 metric tons. Total. Can you do total? Yeah, I think that's probably
This is per capita.
This is per capita. $6,558 million. So $6 billion. 6 billion tons, metric tons of emission that we have emitted in 2019. Time that number by 190 per ton, which goes to about $1 trillion that worth of damage in climate change that we have caused in the year 2019.
Okay, that was a great question. We have one from Zoom. The inclusion of medical costs of high temperatures seem to address only Medicaid, such as it is in Florida. What about Medicare, and especially those who cannot afford insurance? What's the increased rate of death? Do analyses of costs of increasing temperature include the impact on agriculture and starvation and consequent mass population movements? Wow, and how to factor in water scarcity. We have another 3 hours for you, Dr. Z.
I've short answers to it. Liz, I'm working on it. The slightly longer answer is the reason why that graph only shows Medicaid is those researchers from Mathematica, policy research, they only have access to Medicaid data. I don't have access to Medicare data because for obvious privacy reasons, we don't get full details of what people do and what type of disease they have. So even Medicare data is highly sensitive in that sense. So, but we're working on it. We're working with the government to give us the data so that we can do research. But
Okay, Alice?
sorry.
Oh, this is not a question, but it's in support of what you're saying. I went to Key West about 2 months ago, and having lived near the water, I was expecting it to be breezy and lovely. And when we got there, we had planned to walk around Key West. We walked about 3 blocks, and because of the temperature and humidity, we were exhausted. And I still marvel when I think of that. So I really feel for the people who have no air conditioning. Thank you.
Do you want to comment on her? No.
Yeah, I completely agree with what you said. I won't subject my 2-year-old into that condition as well if I have the ability to. But then many of these people don't really have the capacity to do what to have the ability to choose what they can do, as many of us here have.
James, the solutions don't seem personal. I mean, we can all do our little thing, but they're political solutions. What's your read on the acceptability at higher levels of government of actually incorporating some of these costs? Or what can we do, what can an individual do to help with that?
Thank you.
That's an excellent question. I personally believe, and this is not the view of my employer, the University of Florida, disclaimer, is that the best we can do is a sort of program like the Inflation Reduction Act, where we at least do something. And the other part I should say is the political reason why we can't address the issue is people really don't support it. And especially when they think about the amount of money they will have to pay, essentially as a tax to address climate change, that's where it scares people off. But then we know that we're a nation of good. We're not obnoxious people. As a nation, we're not obnoxious. We really care about our neighbors. But then I think people really need the awareness of the really exacerbating damages that climate change and air pollution is really due to us. And I think some of the works that have been doing that calls for citizen awareness is really, really key to change it.
And so, the reason that we're doing these conversations is to help you have conversations with other people. And if you take anything away, if I take anything away, it's the slide where coal really costs 18 cents to produce and not 7 cents to produce. And that's a fact. And it makes it very expensive. So that's really good. We have one question here, one more from Zoom, and then I know I get the cut your throat sign.
Have you thought of or projected how the climate change might affect immigration from south to north in those countries that are energy deficient?
Are you talking about immigrating from the global south to the global north? Or are you talking about from Florida to Illinois?
Global.
You're talking about global. Okay. There has been research showing that the more severe the countries that a community faces, especially in the global south, they're more likely to immigrate into wealthier and mostly into wealthier countries in Europe and here in the United States. It's a known problem, but then it's probably we as a society need to think about how to deal with it when they flows in. And I know it gets super political when you think about immigrants these days. But I tend to think about it as they're fleeing because they want the same choice that we here have. They really don't have a choice. That's why they abandon their homeland in the first place. No one wants to really voluntarily leave where they live for the past 40, 50 years, if not because of lack of choice.
Okay, we have a question online. I recently read an article online asserting that considering all externalities, self-charging hybrids such as Prius have the least carbon or environmental impact of vehicles, including electric vehicles. Have you seen anything about that in the scientific literature? Considering all externalities.
I don't have specific knowledge to that, but I would believe the statement is, in my educated guess would be it's correct, but I haven't seen the scientific literature. Sorry, Phyllis. But then the other thing is, if you know such literature, please send it to me.
Okay, Phyllis, you got that? We'll make sure that you get email for Dr. Xi. Last question.
Has there been any thought about going back and changing our architects? I grew up in Southern California, and 108, there was no air conditioning. We sat outside, and we definitely dressed different. You go look at the old schools in Florida, they had cross ventilation. They did not have boxes. Look at the old Florida houses, they all had ceiling fans. And definitely the cracker houses were built so they vented the heat out the top. Has anybody talked about going back to those previous old-fashioned ways?
First, I'm sure there's one, and there's might be two. I'm fully. I think that's a good way of doing it. But then if I may expand that on a bit. We know that climate is changing, and we can't, and we as a society need to find ways to really mitigate that impact. We know it's bad, but then we are humans. We invent stuff. I mean, we create stuff we change stuff in order to make our lives better, right? From the pre-modern architecture designs, which I've seen in one of the southern Florida ones when I do a road trip there, to lead programs. So there are newer ways. I'm not an architect, so I can't comment, to really weatherize our grid system in Texas, right? They haven't seen the cold, and I think 2 years ago, the winter snow broke their systems up. Hundreds of people are causing sufferings in there. And we can change this, but then we as a society really need to think about if we can't get get carbon emissions to go down, at least think about what's the best way to deal with it. And that includes essentially localized solutions, right? I mean, there's not one shoe fits all.
Okay,
Yeah.
one last one. Thank you.
I just wanted to comment on the fact that I have been doing research on architecture and found that there is quite a lot of underground housing that is being explored at this point, which of course largely eliminates the need for heat or air conditioning and also preserves other components of resiliency and how we can manage. These are not, holes in the ground or bunkers, but these are things that are built into maybe dunes or into cliffs and so on that have plenty of light and yet still are totally energy efficient.
And in closing, I want to address something that you said about use the Inflation Reduction Act carrot, but there is a stick in Congress. It's called the Energy Innovation and Dividend Act. It's bipartisan, and it is trying to put a tax, a fee on extractive industries where the extraction takes place. And yes, that will raise the cost of using energy to recognize these externalities. And that extra money will be returned in a monthly check to every single American. The lower income folks will actually possibly end up with more money in their pocket even after increased energy costs. Higher income folks, well, okay, you can buy an extra $15 hamburger, but you don't need that help as much. So it's carrot and stick, and that would be a good thing to support with legislators. And that is when you say, what can we do? Just keep the pressure on our elected officials and get the right kind of folks in. Dr. James, you've been fabulous. Thank you. It's a fantastic program. Next week, we have our own Bob Bernstein talking about sea level rise in Florida particularly. And then remember, we're having a makeup session with Dr. Ken Sassaman on paleo humans and climate change on Monday, the 21st. So we'll see you all next Thursday.